Welcome back, everyone. Let's look at the now you try problem where we determine whether a graph is a function or not, and looking at the domain and range of each. So the first graph that we're going to look at, it's largely a straight line, but it's got some interesting extra things going on here. It starts in the bottom left around, it's like -7, -1.5, and then it has a constant slope all the way to the top right at the point 7, 5.5. That's what it looks like. And there are arrows indicating that this continues to the left and down and up to the right as well, but it has some holes in it. There's a hole on this line at -4, 0. There's a hole on this line at 2, 3, and there's another hole at 6, 5. But there are also some points on this graph. There's the point at -4, 4. It's a filled in circle. It's just a single point though. And then there's a point at 2, 1. So as I look at this line and I kind of scroll along it from left to right, I read these and say, okay, if I'm moving along this line from left to right, if I look at any x value here, is there any place where there's two y values? So if I look at -4, there's a hole at -4, 0, so that's not an output. We're saying that if x equals -4, this does not output 0 because of that open circle. It only outputs +4, the closed circle above the line. Similarly, when x equals +2, there's a hole on the line at 2, 3, so the x value of 2 will not output the y value of 3. It will only output the y value of 1 at the point below the hole. So if x is 2, this only outputs 1. If we look at any other x value, like -2, we can just look at the line and say at -2 on the line, we're at the point -2, 1. So if x is -2, this would just output 1. If we look at an x value of 6, we actually see that there's no output because there's an open circle there and there's no point above or below that open circle to say that there's a different output for that x value. So as we look along here and we think about, even these special circumstances where there's these open circles, there's still only a single output for each input. And for 6, there's no output, and that's okay. That just means that 6 is not part of the domain. In fact, let's note that real quick. The domain for this function, we can put in every x value from -infinity up to 6. And then we can input every x value after 6. We just can't input 6, or I could put this as the set of x such that x cannot equal 6. This is a really nice way of writing. I like using the set notation if there's just a single value that we're not including here. And again, as I think about this, the line has an arrow pointing down to the left, so it keeps going to the left for forever. And then it seems like there's a break when x is -4, but we see that the function does have an output when x is -4. It is +4. So -4 is also part of the domain. Then we see the line continues without any breaks from -4 to +2. And then at +2, there's a break, but there's a hole on the line, so 2, 3 is not a point on the line. But if x is 2, we do get an output of 1, so 2 is part of the domain. We continue along the line. There's no other breaks there until we get to the point 6, 5, at which point we realize if x is 6, there is no output. There's no y value. There's no point on the line that has an x value of 6. And there's no point anywhere on this coordinate plane that has an x value of 6. So 6 is not in the domain. But then we look to the right of the point 6, 5, and the line continues up to the right and has no other breaks. So 6 is the only thing excluded from the domain. And we can say that, yes, this is a function. Each x value only outputs a single y value. Now we still need to talk about the range. It's going to be a little bit trickier here, but it's not too bad. So I want to say all the possible y values. So I start by thinking at the bottom left, that arrow is pointing down to the left, and it keeps going down for forever. So we can get all of the y values that are like negative infinity up to something. But as I scroll along this, I realize that as I come up the line from the bottom left, we have the y value of 0 is skipped. If I look left and right along the x-axis, there's no point anywhere on this graph that has a y value of 0. So we're going to skip 0 by saying negative infinity to 0, then close a parentheses, and then put a union to say we're going to pick the range back up after 0. And then we can see that the y values from 0 to 3, as I continue going up the line, all the y values from 0 to 3 are included. None of those are skipped, but 3 is skipped, right? If I look left and right from a y value of 3, there's no point that has a y value of 3. So we're going to skip 3. And then we continue up the line, and we see that the y value of 5 might be skipped as well. As I look left and right along a y value of 5, again, there's no point with a y value of 5. So we will go from 3 to 5, but then skip 5. And then the line does continue up and to the right for forever, so this will go up to infinity after 5. The other 2 points, the 2, 1 and the negative 4, 4, those have y values of 1 and 4, and those are already accounted for as we looked along the line. We don't have to now plug them in again or state them again. I can also write this range in set builder notation. This equals the set of y values such that y does not equal 0, 3, or 5. And that's implying that it can be any other y value. Okay, that's actually probably the hardest one of this group of questions here. Let's zoom in on part B and take a look at this. So this is kind of interesting. We have some points. The first point is at negative 6, 4. And we have a point at negative 5.5, it looks like, comma 3.2 maybe, hard to tell. And we've got the next point at negative 5, comma 3.2. And we've got a point at negative 4.5, looks like, comma 3.2. Then we have a solid filled in circle at negative 4, comma 3.2. And from off to the right of that filled in point, we have a line that continues to the right for forever, just a horizontal line, no going up or going down. So as I think about that, each x value, as I've looked at this from left to right, no x value has more than one y value. So we can say that this is a function. Right, if I look at any x value, I don't get 2 points above and below each other, indicating that there's 2 outputs for that x value. So yes, this is a function. Each x value only has one y value, or could be a little bit more descriptive, for each x value in the domain, there's only a single point on the graph. So only one y value for each x value, right? Only one output per input. All right, let's look at the domain. The domain is going to equal. This is kind of interesting. We've got a set of points to start. We can say x can be -6. It can be -5.5. Then it could be -5. It could be -4.5. I'm going to close this set now and now union this with an interval, because after this there's a continuation of x values that it can be. It can be all the x values starting at -4 and going to the right for forever all the way up to infinity. Now the range is actually pretty simple. It's only two different y values that we can get out for this. We can get the y value of 3.2 out, and we can get the y value of 4 out. If we look at all of the different points on this graph, the individual points and the line, all of the points on the line have a y value of 3.2, and then the individual points have a y value of either 3.2 or 4, and that's it. So the range is just two different values here. All right, let's move on to part C. Wrap this up. Here we have a squiggly line. It starts like an arrow pointing out to the left, and then it moves to the right, and then it turns back to the left around the point 3.3, 1.6-ish, and then it goes to the left, and then it comes down and to the point about -0.1, 0.3, and then it turns back to the right again until it gets to the point about 0.2, -0.4, give or take, and then it goes back to the left until it gets to the point -1.2, -1.4-ish, 1.3, I don't know, 1.4 is fine. And then it turns back to the right, and it keeps going to the right and down for forever. So if I look at any of the x values, if I look at the x value of -1.2, and then I look at all the x values between there and up to the x value of 3.3, we see that any of these x values in here are going to have multiple points on the graph with those x values. In other words, we see that these x values will have more than one output. And that's not just at the whole number x values, but any of them. We're going to see more than one output. If x is between -1.2 and 3.3, there are multiple points on the graph with these x values. So more than one output or y value for these inputs. So this is not a function. All right, even though it's not a function, we can still talk about its domain and range. The domain is going to be everything from -infinity to +infinity. As we look at this, we can plug in an x value all the way to the left. The line keeps going to the left for forever, so we're getting all the x values out there. And it comes and it squiggles back and forth, you know, between -1.2 and 3.3, but we can plug those x values in, and we just get more than one output, more than one y value for each of those inputs. And then it does turn back to the right, and it keeps moving to the right for forever, so no x values are skipped. Similarly, the range is -infinity to infinity. If we look up and down on this graph, it's hard to tell, but the line does keep going up for forever, and it does keep going down for forever. as we look at those arrows, it is indicating that that's continuing on in the up and down directions as well as the left and right. And in the up and down direction, in the y direction, we aren't skipping any y values. If there's any y value that we want, we can find a point on the line with that y value. And so the range is also all real numbers. All right, that concludes this video on determining if a graph is a function and reiterating how to find the domain and range of a relationship in a graphical form. Thanks so much for watching, and we will catch you in the next video.